Today I'll show you how to modify the UniVRM plugin and write a script to make your character turn their head to look at nearby objects. You might find this behavior is similar to the one implemented in the game Genshin Impact, where the characters can look at nearby objects. This tutorial is part 4 of my previous tutorials, so I highly recommend you watch the previous one about blinking and eye tracking using the UniVRM plugin. First, we're going to modify the UniVRM plugin to also move the head of our character. Let's search for the VRM Look at Bone Applier script from the project window and open it. So let's create a new reference to the head transform here. And then we'll scroll down until we find the Apply Rotations function. At the very end of this function, before the curly bracket, we'll type in this code. What this does is that after we make sure that the reference to the head transform exists, we use the lookAt function to rotate our head according to the calculation made earlier in the script. Or, in other words, we're applying the rotation of the eyes to the head object. Save the script, and then in the hierarchy window, we'll search for head, and drag this to the field we just created in the VRM Look at Bone Applier. Now, run the game in play mode. Let's move the target object, and it works! Our character is now moving their head towards the target object. There is just one problem here. If we move our target to the back of the character, oh okay, that's a scene straight from the horror movie. We're going to address this later in the video. Now it is time for us to make our character look at nearby objects. So first of all, we need to create the objects we're trying to look at. Let's keep it simple by creating a cube with a new material set to green color. Let's make a multiple of it, space it apart, and put it to the right and left of the character's path. Now let's create a new cube as a child of the character's object. This is going to be our lookAt collider to detect nearby objects. Let's give it a new transparent yellow material so we can see it better. To create a transparent material, change the rendering mode to transparent and then adjust the A value in the color wheel. Then on its box collider property, we'll set isTrigger to true. Let's adjust the size of the collider. The size of the box determines how far the character will turn their heads to follow that object. Also, make sure the box doesn't touch the character or the ground. So, here is how we take care of the character's head horror problem. By making sure that the collider is positioned in front of the character will never look to the objects behind them. We're going to set a script to only allow the character to look at objects that are in this collider. So let's create a new script in the project window and name it Look and open it in Visual Studio. First, we need to create a reference to the target object to be able to manipulate its location. We also need a variable to store the current nearest object to the character. Then, we write that when a new object enters the character's line of sight, we'll make it the nearest object. And then, when that object leaves the line of sight, that object is no longer the nearest object. We also need to create a function to move our target object to the location of that nearest object, so the character will look there. Don't forget to call this function in the update function. Also, don't forget to save our work here. Back in Unity, we'll first put the script into the lookAt collider inspector. Drag in the target object from the project window to the target field we just created. On our character object, let's enable the root motion on the character animator so the character can actually start to move forward. We also need to remove a collider from the target object since it's unnecessary and can block us from properly moving the target into the proper location. We then need to add a rigid body to the look-at collider so the collision detection can work. Let's disable Use Gravity option on this rigid body. When we go to play mode, it's sort of working. The character is now instantly looking at some of the objects, but it's not always the closest one. This is because our current code doesn't take into account if there are multiple objects inside the look-at collider. There are different approaches we could take here, but for the sake of performance, I'm going to refer back to Genshin Impact's implementation. In this clip, you could see that the character is locked onto the first nearest object that it sees and ignores other objects around it. It will only change the current look target when that object leaves their line of sight. That might sound complex, but don't worry, we'll do it together step by step. So, we want to open up our script again in Visual Studio. The first thing we want to do is to create a list to keep track of all objects that are currently inside the collider. Let's call this list Objects in Sight. In the onTriggerEnter function, we want to add this code. This means that when an object enters our character's line of sight, if there is no object being looked at, we'll immediately look at that object and then we'll add it to the list. This if statement over here is just to avoid adding the same objects twice into the list. Now, we need to modify the onTriggerExit function to remove the objects that have exited the collider from the list. Once again, this if statement is just to avoid removing the same object twice from the list. Let's add a new condition to check if we are removing the object that is being looked at by the character. If it does, then we'll have to find the nearest object from the list. This find new nearest object function doesn't exist right now, so let's go ahead and make it. So there are several possible things that could happen when we're trying to choose another object from the list. The first possibility is that there is no object in the list, which means there is no nearby object to look at. If that is the case, then we'll just set the nearest object to nothing, so the character won't look at anything. The second possibility is that there is just one object in the list, so we'll just immediately set that object to be the current nearest object. The third possibility is that there are more than one item in the list. If that is the case, then we need to do a loop to compare all the objects' distance from the character's location and pick the closest. But first, we need a new reference to the character's current location. Let's create a new reference to the character's face. And then, let's go back to the find nearest object function, where we'll do a loop to compare the distance of every item in the list to the character's face. At the end of the loop, we'll find the nearest object to our character. Once again, don't forget to save and return to Unity. Let's assign the character's face by searching and dragging it to the inspector. When we go to the play mode, we'll see that the character is now properly looking at the nearest object every time. Nice! The next part is to smooth the transition when our character turns their head to look at another object. Let's go back to Visual Studio and scroll down to the Move Target Look At function. There are several smoothing functions that we can use, like Move Towards, Lerp, or Smooth Damp. I'm going to link you guys to a video that explains the difference between these three functions. For this tutorial, we're going to use Smooth Damp because I think it looks the best. So we're going to add Vector 3 Smooth Damp and then the target current position. And here we can see that this function needs a reference to a velocity variable to make its calculation. So let's just give it a new variable and fill in the function with a ref keyword. The last part of this function is the smoothing timing. The bigger the value, the slower the head will turn. Let's just create a new variable so that we can change the value from the inspector. Then don't forget to multiply it with time.delta_time. We also need the head to look forward when there is no object to look at. So let's copy-paste this line and change the target to our character's face, add it with this vector 3 value so that it will look forward. Save the script and return to Unity. Let's set the smooth time to 25, and then when we go to the play mode, now our character will turn their head slowly from one object to another. Yay! So far, we have successfully made it so that our character will look at any object with a physics collider. But what if we don't want our character to look at a certain object? Back in the previous Genshin Impact video clip, our character doesn't look at the ground even though they clearly collide with it. In this funny clip, we can see that some characters in Genshin Impact refuse to look at certain characters. So how do we do this? There are two ways to do this. The first one is to use a collision layer, and the second one is to use tags. Let's first create objects we don't want to look at. In this case, it's a simple wall made out of box with blue material. To make it more obvious, I'm going to move the green cubes so that the player can focus on the blue walls. Let's enter the play mode, and we'll see that the player right now is looking at both of the blue walls. Alright, so we're going to implement the collision layer to the first blue wall. Let's click on the first blue wall in the project window, and in the top right part of the inspector, we're going to click on the layer drop-down menu. Then click on Add Layer. We can fill in any empty field with any names we want, but I'm going to fill it with wall. Let's click on the first blue wall again in the project window, and we can now select wall from the layer drop-down menu. Now, in the Unity menu, open up Edit, Project Settings, and we want to open up the Physics menu and look at this collision matrix. This collision matrix determines which collision layer can interact with other collision layers. If the box is unchecked, then any collision between those two layers will not call in any collision event. Our Look at Collider layer is set to default, and our Object Not to Look at layer is set to wall. So to make them not interact with one another, we'll just uncheck this box. When we go to play mode, we can see that our character now ignores the first blue wall. Great! The major advantage of using this method is that you can ignore a lot of objects all at once, like the terrain, foliages, and buildings once you assign their collision layers. You also save a lot of computer resources because the game just ignores collisions between the two layers. But the downside is that we can't set a specific object to not look at. To set the collider to ignore a specific object, we're going to need to use tags. The process is quite similar to setting up the collision layer. Let's click on the second blue wall in the project window. In the top side of the inspector, just to the left of the layer drop-down menu, we have the tag drop-down menu. Open the tag drop-down menu and choose Add Tag. Click on the plus icon here and type in wall. Let's click on our second wall again in the project window and now assign the wall tag. Instead of going to the collision matrix, we now have to specify the look script to ignore this specific tag. So let's open the look script in the Visual Studio, and in the beginning of the onTriggerEnter function, we write that if there is a collider with the tag wall, we skip it and just end this function. Save the script and go back to Unity. And in the play mode, now our character also ignores the second wall. As I said before, this method works great if you have a specific object that the character shouldn't look at, like a certain other character or object that your character doesn't like. But the downside is that now, at every collision event, even with objects that are not the wall, our game will need to check if that object doesn't have the wall tag before doing anything else, which is okay if you only have one tag excluded. But when you have multiple tags, the performance may take a huge hit. So you'll need to consider which method to use. So this next part is entirely optional, but I will briefly mention two optimizations that you could do to the look script in the Visual Studio. The first optimization is to change our vector3 distance function to square magnitude. The second optimization is a tiny loop modification to avoid unnecessary distance calculation between the character's face and the current nearest object. I'll leave a small description in look script if you want to learn more. Alright, so that concludes our two-part tutorial on eye and head tracking in Unity with VRoid characters. And if you want to see more tutorials like this, then be sure to subscribe and ring the bell so you'll be notified when a new video comes out. And with that, I think I'll see you guys later. Goodbye!